Solution of assignment 3. In first question, we have to expand a plus b whole raised to power 4 using the binomial theorem. So as we know that for the binomial theorem, a plus b whole raised to power n, it is written as nc0 a raised to power n b raised to power 0 plus nc1 a raised to power n minus 1 b raised to power 1 plus nc2 a raised to power n minus 2 b raised to power 2. In the same order, the last term will be written as ncn a raised to power n minus n and b raised to power n. Here the value of n is equals to 4. Just substitute 4 in place of n. So we get in next step a plus b whole raised to power 4 is written as 4c0 a raised to power 4 b raised to power 0 plus 4c1 a raised to power 4 minus 1 b raised to power 1 plus 4c2 a raised to power 4 minus 2 b raised to power 2 plus 4c3 a raised to power 4 minus 3 b raised to power 3, and the last term will be 4c4 a raised to power 4 minus 4 and b raised to power 4. The next step, we will calculate the value of 4c0. It is 4 factorial divided by 0 factorial, then 4 minus 0 factorial. It will be equal to 4 factorial divided by 4 factorial and factorial 0. As we solve, factorial 4 written as 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by factorial 4 multiplied by 3 multiplied by 2 multiplied by 1, and the value of factorial 0, this is also 1. So as we solve, we get 1. Similarly, value of 4c1, it is factorial 4 divided by factorial 1 in bracket 4 minus 1 factorial. Now as we simplify, we get 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by 1 factorial 1, it will be equal to 1, and multiplied by factorial 3 written as 3 multiplied by 2 multiplied by 1. Now solve it. 4. Now we can find the value of 4c2. It is 6. The value of 4c2 equal to 6. Now the value of, in the same order, we will calculate the value of 4c3. It is 4. And in the same order, the value of 4c4. As we simplify it, we get 1. Now substitute these values in above expression. In place of 4c0, we will substitute 1. In place of 4c1, we will substitute 4, and so on. A plus b whole raised to power 4 is equals to a raised to power 4 first term plus 4 a raised to power 3 b plus 6 a raised to power 2 b raised to power 2 plus 4 a b raised to power 3 plus b raised to power 4. So that will be the solution. Now the solution of question number 2. In question number 2, as we compare with a plus b whole raised to power n, the value of a in place of a here given x, in place of b given as 2y, and in place of n 5. Now we can expand using binomial theorem. So x plus 2y whole raised to power 5 written as 5c0 x raised to power 5 2y raised to power 0, then 5c1 x raised to power 5 minus 1 2y raised to power 1 plus 5c2 x raised to power 5 minus 2 2y whole square plus 5c3 x raised to power 5 minus 3 2y whole cube plus 5c4 x raised to power 5 minus 4 2y whole raised to power 4, and the last term will be 5c5 x raised to power 5 minus 5 and 2y whole raised to power 5. Calculate the value of 5c naught, it is equal to 1. Value of 5c1, it is equal to 5. Value of 5c2, it is equal to 10. Value of 5c3, it is equal to 10. Now the value of 5c4, it is equal to 5. Value of 5c5, it is equal to 1. As we substitute these values in our expression, we get in question 3, as we compare with the standard expression a plus b whole raised to power n. So in place of a here 1 and in place of b 2x given, and finally the value of n, that is 6. So we can expand that using the binomial theorem. What will be the expansion? A plus 2x whole raised to power 6 equals to 6c0 1 raised to power 6 and 2x raised to power 0. And second term 6c1 1 raised to power 6 minus 1 means 5 and 2x raised to power 1, no need to write 1. And the next term 6c2 1 raised to power 5 1 raised to power 6 minus 2, so it is 4 1 raised to power 4 and 2x whole square will be there. The next term 6c3 1 raised to power 3 and 2x raised to power 3. And next term c64 1 raised to power 2 and 2x raised to power 4. And next term 6c5 1 raised to power 1 and 2x raised to power 5. And the last term 6c6, so 1 raised to power 0 and 2x raised to power 6. Now we will calculate the value of 6C0, that is 1, and then 6C1, that is 6, 6C2, that is 50, 6C3, that is 20, 6C4, that is 15, 6C5, that is 6, and finally value of 6C6, that is also 1. Now we will substitute these values in above expression. So we get 1 plus 2x whole raised to power 6 is equals to, this is 1. Any power we raise on 1, that will be 1, and value of 6C0, that is also 1. So first term, and 2x whole raised to power 0, this is also 1, so first term will be 1. Now second term, value of 6C1, 6, and multiplied by 2, so that is 12x. Now next term, value of 6C2, that is 15, 15 multiplied by 4, so 15 multiplied by 4, 60x square. Now next term, value of 6C3, 20, 20 multiplied by 8, so it is 160 x cube. Now next term, value of 6C4, that is 15, 15 multiplied by 16, 15 multiplied by 16, as we solve, we get x raised to power 4. Similarly, value of 6C5, that is 6, and 6 multiplied by 2 raised to power 5, 6 multiplied by 2 raised to power, as we solve, it is 192 x raised to power 5, and the last term will be 64 x raised to power 6. So this is the answer. This is the solution of the whole assignment.